Hello. So, cybersecurity is a big issue these days. You must have heard about people getting their identity stolen or people getting their accounts hacked. Even big corporations, like recently Nvidia got their account hacked and they had a lot of intellectual property stolen by hackers. So, cybersecurity is a deep topic and it's not possible to cover the entire spectrum in just one video. But suffice to say that you should definitely take a course on cyber security and how to protect yourself, even if you're not a technical person. You should know the basic etiquettes of having a strong password. What does it mean to have a strong password? How do you secure and store your password in wallets, etc. So you can find many YouTube videos on how to do that, or maybe there are some courses also which you can take. But in this particular video, we are going to talk about storing your passwords on pieces of paper. Now, prima facie, it may look like a terrible idea. Why would you want to store your passwords on paper? Why not use something like LastPass or KeePass to store your passwords? So, there are two articles which I can point you to and I will link you to that. There is a rule in storing your data, and that is called a 3 to 1 rule. So you must always have 3 copies of your data in 2 different media, and one of them should be offsite. Believe it or not, that many a times your chances of getting hacked online, having your data stolen online, is more probable than somebody breaking into your house and stealing your stuff. So you can take all your important passwords, like for example, password for your email account, your bank account number, your social security number, the important numbers and passwords which you absolutely require to run your life. And it is completely valid option to write them on a piece of paper and store them with other valuable papers that you keep in your house or in a bank locker or wherever you keep your important stuff. Uh, let's say your gold or silver. I hope you have some gold and silver. So you save your paper with those things. Now the question is it a good idea to just store your password as plain text? Of course not. It is never a good idea to write your password in a plain text, because if somebody can get hold of that password, they can of course exploit that. So we are going to use a technique called Wagoneer cipher to securely write down your passwords on a piece of paper. And in its original form, the Wagoneer cipher can only contain letters from capital A to capital Z, that is 26 letters. It cannot contain small letters and it cannot contain special characters. What I have done is I have modified it a little bit so that you can actually use special characters also and lowercase characters also. And it's not very difficult to do. And this is how the process is. Let's say, for example, your password is my super secret password. So you can read it over here. MY for S, I have used the dollar sign. SUPER SECRET and PASSWORD. And O is 0. I've replaced O with 0. You could have a different password. That's completely fine. I'm just using this dummy password to demonstrate the concept. Now what I want to do is I want to write it on a piece of paper and store it somewhere. Now what I will do is I will first of all write the ASCII number for every character. And what is the ASCII number? ASCII stands for American Standard Code for Information Exchange. You can find this chart in many books. You can find it online also. So if you go to Google and search for ASCII table, you will get something like this. This is the ASCII table. And you can see that, 32 is space, 33 is the exclamation mark, and 126 is the wavy sign. I don't know what you call that. So maybe tilde or something, tilde. And 125 is the curly brace, closing curly brace, so on and so forth. So these are all the characters, special characters. Then you have capital A to Z, and then you have some special characters. Then you have A to Z. So what we will be doing is we are going to be using from 32 till 126. All these characters we are going to be using from 32 to 126. If you don't want to use all the characters, you can narrow down the range to the character that you want to use. Now, let's say, for example, M. M has a ASCII character of 77. You can check it. If you go to 77, that is M. Similarly, small y has 121. So if you go to 121, that is a small y. Dollar sign has 36. So if you go to 36, that's the dollar sign. So what you will do is you will write the ASCII character for all the letters of your password, and you can do it on a piece of paper also, but make sure you draw the columns. Do it on a grid kind of a paper, or you draw the grid and then do it because you don't want to mix the characters because of alignment. So once you do that, once you write all your ASCII characters, what we are going to do is we are going to define a range. Like I told you, I have used range from 32 to 126. I've included the space also because certain seed phrases contain space. If you don't want to use the space, you can start from 33 also. So in other words, from 32, you can change it to 33. That is also a valid approach. So now we are going to be using the space also, but do keep in mind when you are using a space, when you encrypt your password, make sure that there is no, you take the entire password. There should be no trailing space at the beginning or the end, which you fail to see or miss. So if you just want to be safe and secure, maybe you leave the spaces out. For the demonstration purposes, I am showing you the space also because space is something that you cannot see. So now what you do is after you write all the characters over here, you create a password. This is a password that you should keep it in your mind. You should remember it. You can also use Shamir's secret to save this password with other people if you want. That's another video which I've already created. You can check my channel, but it should be a phrase which you remember. In my case, I've chosen the phrase vegan for life, VEGAN for LIFE. So this is the password. And this is a small I. The problem is in LibreOffice, I'm not able to find the option to turn auto correction off. So if I put a small I, it will automatically convert it to capital I, which is okay because we are only concerned about the ASCII number. As you can see, 105 is small I. So this is small I. All the password is in small characters. So then what you do is you write your password below your actual password, your keyword below the password. And the next thing that you need to do is, this is also part of the password, exclamation mark. So this is the password VEGAN for LIFE and exclamation mark. This is the keyword. Now what you will do is you will keep repeating the keyword till you exhaust or come to the end of your plain text, which means in this particular case, this is another repeat VEGAN for LIFE, but we will not put any exclamation mark here. We will stop when this ends. So again, to repeat it, we are simply writing the password back to back and terminating it when this ends. Let's say, for example, your password was book. So you can write, I'm just giving an example, BOOK, and then you keep repeating the book as such. But you see here, we overshoot the password. So we don't want this. We just get rid of these 3 characters and we are left with just one B. So study this carefully. How we are doing it, it's not very difficult. You just keep repeating the key phrase till you come to the end of your actual password. Okay. So I hope you can see this pattern over here. Next thing, you do the same thing. You write the ASCII code for all the characters of your password. So in this case, you can see V is 118. So V is 118. E is 101. E is 101. So that's a E. So on and so forth. Exclamation point is 33. Exclamation mark is a 33, as you can see here. So, and these numbers also repeat. So they go from 118 to 33, 118 to Now there is no 33 because the password terminates over here. Now what you need to do is you need to apply the formula to convert this 77 to some encrypted character which you will use as a password. For that, you need to know the formula, and it's a good idea to also print the formula on a piece of paper and keep it with you so that you don't forget the formula. And what is the formula? This is the formula. Now it looks complicated, but actually it's not. It's very simple. It's just addition, subtraction, division. So, but before I explain you the formula, you need to know what is a mod. Mod basically means remainder. So for example, if you have a number 9 and you want to divide the number 9 by 2. So what do you do? If you divide the number 9 by 2, so you can say 2 fourths are 8 and the remainder is 1. So this is your quotient. This is the remainder. Modding gives you the remainder. That's all it means. It means that you do this, then you mod it, you divide it with this and keep the remainder. So let's understand the formula. The formula is, now keep in mind, P is the plain text. P is the plain text minus the minimum, which is your minimum ASCII range, plus the keyword, K is your keyword, minus minimum, and then you mod it with max plus 1 minus minimum, and to the whole thing you add the minimum. The whole thing you add the minimum. So let's see this in example. Let's say for example we have two characters over here. We have 77 and we have 118. So what we will do is we'll take these two characters, 77. So in this case the plain character is 77 and the encrypted character is your keyword is 118. So that's your encrypted character, and the minimum ASCII range is 32 and the maximum is 126. So we'll take a look at decryption later, but this is how we are going to work with. So this 118 is going to be substituted for your plain character. So no, 118 is your keyword, so that is your key character. 77 is your plain character. That's it. This is where it's going to go. So we will say 77 minus the minimum, which is 32, plus your key 118 minus minimum. Then take a mod with max plus 1, which is 126 plus 1 minus 32, and add 32 to the entire thing. Add 32 to the entire result that you get. So if you solve that, you should get this value. I've fed the same formula over here and you get 68. So this is the formula. If in case you want to see, now these dollar signs means I've frozen those cells. This minus this plus this purple minus this, and we are modding it with this plus 1 minus minimum and adding minimum to the whole thing. This is the formula, and we get 68, and I drag the formula all across. So then you get 95, 107, 87, 95, 121. You get all these numbers. Then again go back to your table, go back to your ASCII table and convert it back. So for example, 68 is a D. If you look at 68, it's a D. 95 is an underscore. So you go to 95, it's an underscore, and 107 is a K. So 107 is a K, so on and so forth. So now your encrypted password is this. This is something you can print on a piece of paper. Now when the time comes to decrypt it, you reverse the process. How do you reverse the process? You take this encrypted string, you write your keyword, again repeating it, either on top of it or underneath it, you write it, and then you apply this formula. So note down this formula. This is the Excel formula. And what we have to do is, if you go here, this is the formula for decryption. Your encrypted character minus minimum minus the key character minus minimum plus max plus 1 minus minimum, mod it with max plus 1 minus minimum, and add minimum to the whole thing. So let's do a recap. So in this case, your encrypted character is 68. So this is going to be 68, and the key character is 118, because that's a V, so 118, and your decrypted character is 68. Encrypted character is 68. So now what you will do is you will simply substitute it. So you will say 68 minus 32, which is the minimum. Remember, this is the minimum, this is the maximum, minus the key, which is 118 minus 32, plus what you are going to do is then max, which is 126 plus 1 minus 32. You mod it with same thing, 126 plus 1 minus 32, and then you add 32 to the entire result, which is the remainder that you get after the division. So once you do that, if you solve it, as you can see, you will get 77 back. 77, when you convert it back to ASCII, will give you M, which is this. So you see, this particular row and this particular row are same. In other words, you were able to take your actual password, you were able to encrypt it to a string. This you can save it on a piece of paper, and when the time comes to decrypt it, you can simply write it down, write your key phrase underneath it by repeating it and truncating it at the end, and then using the formula to generate the password back. Now, I'm not saying this is the only way you should store your password. This is one of the ways, apart from using something like KeePass or LastPass, etc. This is one of the ways you can do it and store it on a different location, somewhere away from your house, like a bank locker or something. So you can, even if somebody finds it, until they know your secret password, they will not be able to decipher it. Okay, so that is how you take it, you encrypt it, decrypt it. Another thing which I have done is, personally, I have created a program, a Python program. So what that Python program basically does is that, let's say for example, I can give it my password, which is my super secret password. I can give it my keyword, I can run it, and it will give me my ciphertext. This is something I can print on my piece of paper and store it somewhere. And I can decrypt it also easily using the program which I have created. And this is what you get, your original password back. Now let's do some demo. Let's say your original password is, this is cool. Let's say this is your original password. And let's say your keyword is book. So if you encrypt it, now this is the encrypted form of your password. This is cool. Like I told you, make sure There are no spaces at the end or the beginning because we are considering spaces. If you don't want to consider spaces, simply start from 33. Then you will not get any spaces. You won't be able to use any spaces in your password also, in your seed phrases, for example. So this is something you need to watch out for when you are programming. And similarly, we can decrypt it back also, and we can get our original password back, which is called "this is cool." So I hope you enjoyed today's demonstration of storing your password on a piece of paper. And I will see you in the next one. Take care. Stay safe.